Alright, so today we are going over Chapter 1, Foundations of Algebra, Lesson 1.1, Variables and Expressions. Again, go ahead and fill in your name where it says name. Mine says Mr. Yurko, yours should say your name, and these are under notes, okay? Alright, so the warm-up. We do not have a warm-up for today as this is the first lesson. Our essential understanding, okay? So today, basically, you are going to be able to represent mathematical phrases and real-world relationships using symbols and operations. Sounds complicated, and essentially, what I want you guys to know is basically we're turning words into math. So go ahead down below, put turning, oops, that's 2. Sorry about that. You are turning words into math. Okay? So that is what we are doing today. Definitions. Okay, so we've got a few definitions here. The ones in red you guys need to copy down. The first one is a variable. A variable is a symbol, usually a letter, and it represents the value of a variable quantity, okay? In other words, all right, I want you guys to put in other words, it's a letter in math. An example would be x. We'll just put x plus 3, and then go ahead and circle x. X would be our variable, okay? Usually variables, so what they do is they stand for a quantity, which is a number, and a lot of the times the math problem will ask you to figure out what the variable is based on the problem. The next definition, algebraic expression, a mathematical phrase that includes one or more variables, okay? So, in other words, we're going to write has a letter, okay? And then our example would be 4a minus 2, okay? A numerical expression, a mathematical phrase involving numbers and operation symbols, but no variables, has numbers only. Okay, so the difference between an algebraic and a numerical, an algebraic has a letter or an unknown quantity, and a numerical only has numbers and operation symbols, okay? So for example, it could be 4 plus 3, okay? Which we all know or should know that that's 7, okay? But since it has no letters, that is why it's a numerical expression, okay? Anything algebraic has a letter where we don't know what the quantity is, okay? Because right now, looking above at the second definition, algebraic expression, right here, we don't know what A is, okay? We do not know what A is. All right, moving on. So example 1. So basically what we are going to do is we're going to take a few examples and we are going to turn them into mathematical expressions, okay? So we have 32 more than a number n, okay? The first thing I want you to do for these problems is circle all the numbers or letters that it gives you. So for example, it gave us 32 and n, and it says 32 more than a number n. Now whenever I see this word than, okay, that means that this 32 is going to go after the n plus 32. Why did I put plus? Because it said more, okay? If it said 32 less than a number n, it would be n minus 32, okay? Now let's look at the second example, okay? We've got 58, which is one number, and n, which is our letter, okay? Now, the key word here is less, but it says 58 less a number n. It doesn't say less than. So whenever we are missing the than, we just write it 58 minus n. If it said 58 less than a number n, in this case, it would be 58 on the or after n, and then subtraction because it says less. 58 less than a number n, okay? N minus 58. So I just want to give you some examples of addition and subtraction, okay? Another word for add would be greater or increase, okay? Words for subtraction would be less, like we have here. It could be take away, minus, okay? All right, moving on. Example 2. So now we are going to deal with multiplication and division. So 8 times a number n. So we've got 8 and n, and our key word here is times, okay? So 8 times, which is multiplication, a number n. Remember, multiplication can be an invisible operator, so you can just write 8n, all right? Another thing to note, if you guys are used to writing 8 times n like this, that is also correct, but guys, we should be getting away from using the multiplication sign as an x. The reason is because in algebra, we are going to be using a lot of like letters to represent, or variables to represent quantities, and x can sometimes be confused with the multiplication sign, okay? So, I'm not going to erase it, but I'll put in red, like a circle, do not use, okay? All right, so now we have our next one. It's written a little bit differently. So the quotient of a number n and 5. So we've got n and 5 as our letter and number, and then the key word here is quotient, okay? So quotient means division, okay? So we know that we're going to be doing division, and it's the quotient of n divided by 5, okay? You could have written it as n divided by 5 with a fraction bar. Either of these would be sufficient, okay? All right. Example 3. Whoa, we've got 2 steps now, okay? So these are a little bit more complex, but it'll be fine. So we're gonna follow the same steps, okay? So for for the first one, we have 3 more than twice a number x. So let's go ahead and circle 3 more than twice a number x. Now there is one more number, and that's twice, okay? So we've got 3 more than is a key word, okay? So more than means 3 is going to come at the end, and twice a number x just means we go 2x plus 3. We did plus because it said more than, and twice a number x would just mean that we have 2 times that number x, okay? If it said 3 more than triple a number x, it would be 3x plus 3, okay? All right, next one. So we've got 9 less than the quotient of 6 and a number x. Now these 2-step ones, we're always going to have 3 circles because there's 3 numbers or letters that we are using in our mathematical expression, okay? Less than is a keyword, and then quotient is also a keyword. Okay, so let's go ahead and write it out. So it says 9 less than, since this than is here, we're going to put 9 at the end. Less means subtraction, so we can already fill that in. And then we've got the quotient of 6 and a number x. So remember, quotient means division, and we have 6 divided by a number x. So it's 6 over x, or 6 divided by x, minus 9. Okay? And the last one. All right, so the product of 4 and the sum of a number x and 7. So we've got 4, x, and 7. Okay? Keywords here, product and sum. So it's the product of 4, so we're going to write 4 times the sum of x and 7. Now, we know that the sum means addition, x plus 7, okay? But it's the sum, it's the product of everything times this. So right now we would be multiplying 4 times x and then just adding 7. We want to multiply it by the whole sum, okay? That's where these parentheses come into play. It's the sum of x and 7 that's being multiplied by 4, not just one or the other, okay? So that's why we have to add this. If you wrote it this way, that is also correct, okay? We can just say that this operation as multiplication is invisible, and we can just leave it as 4 outside the parentheses, all right? Okay, moving on. All right, we've got more 2-step ones in example 4. Okay, so 8 less than the product of a number x and 4. Okay, so we've got 8 less than. Remember, it has than, so 8 is going to go at the end. Less means subtraction, and then our other keyword is product. Okay, so product means 4 and x are being multiplied. So we just have 4x minus 8. Okay, these should be getting pretty simple for you guys. Okay, all right, next one, we've got twice the sum of a number x and 8. Okay, so twice the sum of a number x and 8. Well, we know that sum is addition. We know that twice means 2, okay? But if we're saying twice the sum of something altogether, we know that we need those parentheses, okay? And we've got a number x and 8. So it's just 2 times x plus 8. Because x plus 8 is the sum of x and 8, and it's saying it's twice that. So that's why we multiplied by 2, okay? Next one, the quotient of, so quotient is one of our keywords, 5, and the sum of 12 and a number x. So we've got 3 things circled and 2 in boxes. Now, one thing that I do want to mention, guys, think about it like the ones in boxes are telling you which operation to use, and then the ones that you're circling are just the letters or numbers that are filling in around those operations, okay? So the quotient of 5, so it's going to be 5 divided by something. And it says the quotient of 5 and the sum of 12 and a number x. So it's the quotient of 5 and the whole sum of 12 plus x. So all of 12 plus x has to go as the denominator. Why? Because it's the quotient of the entire sum. If it just said the quotient of 5 and x, it would be 5 over x. But it doesn't say that, okay? It says the quotient of the sum, 12, and a number x. All right? So this would be what yours would look like. If you want to put parentheses around 12 plus x, you can. It's not wrong, okay? Either way is fine. All right, moving on. Example 5, reverse, reverse, 2 hops this time. So whenever I see like the word or hear the word reverse, that's what I think of, is the Cupid shuffle. So from here, for example 5, all we're doing is we're just using words now. So if it gives us like 3x, we are going to be required to write 3 times the number x, or the product 3 and a number x, okay? So it's basically just seeing a mathematical expression and then writing it, turning math into words, okay? The opposite. All right, so example 6. This is more reversage. I don't even know if reversage is a word, but that's what came to my mind when I was writing these notes. So x plus 8.1. We can write the sum of x and 8.1. You could have wrote 8.1 more than x. You could have written x more than 8.1. Any of those would have been fine. I just wrote the sum of x and 8.1. Okay? Next one, we can write 10 times x plus 9. Or 10 times x more than 9. Okay? Basically, you're just writing it out. Okay? The second one, we can write the quotient of n and 3. You could have also written n divided by 3. Okay? Any of those would have been fine. 5x minus 1. Could have wrote the product, which means multiplication of x and 5 less 1, or you could have written 1 less than 5 times x. Okay? Either one of these two would have been okay. All right? Moving on. Actually, there's multiple other ways, but just keep in mind this, whenever you say less than, okay, that means that the 1 is going to go at the end, okay, or more than, it would go at the end. All right, moving on. Example 6, more reversage. Actually, we just did these. I guess I had an extra slide, okay? Practice makes you perfect, okay? So these are some practice problems. I want you guys to go ahead and try these on your own. So you should pause the video now and try them on your own. I'm gonna go ahead and write the answers in. So don't copy down the answers unless you've tried them on your own, okay? So it says, give the algebraic expression for each. The product of 9 and a number t, that would just be 9t. The difference of a number x and 1/2. So x minus 1/2. The sum of a number m and 7.1, m plus 7.1. The quotient of 207 and a number n. Okay? When we have words and we're changing them into an expression, there is only one possible answer. So if you didn't get any of these the same way that I did, you could have gotten it wrong. Now, that's not to say that like you couldn't have written this one as 7.1 plus m. You totally could have done that, okay? But I'm just saying like there's less room for error. Like you couldn't have written 1/2 minus x. If you had written 1/2 minus x, this would have been wrong, okay? All right. More practice. Tell me if these algebraic expressions or tell me if these are algebraic expressions or numerical expressions. In the first one, we don't see any letters, okay? I don't see an X, I don't see an A, I don't see an M. So this would be numerical, simply because we don't see any algebraic things, X, Y, whatever. It's all numbers. So numerical expression. I'm just going to leave EXP, okay? 4m plus 6. M is clearly not a number, so this one's algebraic. And lastly, 2 times 5 minus 4. That's numerical. Why is it numerical? Well, even though it's more complicated than the first one, it's still only numbers. There's no letter involved in that expression. All right, and this brings us to our last slide, okay? So again, you should be practicing these on your own and then just checking your answers. So if you need to pause the video now, do so. It says use words to describe each algebraic expression. 6c, 6 times a number, or just 6 times c. X minus 1, 1 less than x. Keep in mind, guys, there are more than one way to write these out, okay? You could have said x less 1, multiple different ways, x minus 1. So there's different ways to write these all out in this regard, okay? In the other way, when we had, let me take you, t divided by 2, you could have written quotient of t and 2. And then the last one, we have 3t minus 4. 3 times t less 4. Okay? Oh, this should be times. All right, and that was my last slide. So you guys have the homework now. Go ahead and get started on the homework. If you have any questions, just shoot me an email. All right, thanks, bye.